The purpose of this lesson is to instruct you on how to find the surface area of composite solids. A composite solid or a composite figure is an object or a figure that's made up of two or more objects. The first two that you have in your notes. All right, so for letter A, well actually, hold on one second. When you find the total surface area of these figures, what you're looking at is for the surfaces that would be painted. What I mean by painted is, think about, for instance, if you wanted, like I said, to paint, you would paint all of these flat surfaces. Oopsies. You would paint all of these surfaces in here. And you'd paint the back one, and you'd paint the side one, probably tip it over and paint the bottom. You'd paint these four triangles, but the one thing that would not get painted that doesn't really exist here is this square right in the middle. Yeah, I know we see it. Yes, I know I can draw on it, but these two things are glued together. It's solid, or think of it maybe as being open all the way through. This is a container that can be filled up to the very tippy top with whatever you want to put in it. So there really is no square separating these two surfaces. So the way that I'm going to go about this, I have good luck when I kind of redraw the shapes, and I know everybody's drawing ability is different. Let me get back to my pen. But I recognize that I have this pyramid and I have a prism. But what I need to do is if I find the area of the pyramid, it's going to include that bottom. And if I find the surface area of the prism, it's going to include that top. So what I'm ultimately going to do is subtract two of these squares so that it's not counted in my surface area. All right, so let's go ahead. I'm going to find surface area. Let me erase this up here. I'm going to find surface area of each figure, and then like I said, I'm going to subtract out that square that's in the center of them. So the surface area of a pyramid is capital B plus 1/2 PL. Surface area of a prism, and then I'm going to subtract, and for that rectangle, it'll just be length times width, or base times height, whatever you want to call it. So think about the base. The base of this square is 2 by 2, so 4, plus 1/2, the perimeter, 2 plus 2 plus 2 plus 2, 2, 4, 6, 8. And then I need slant height. What was given to me, that 2, is actually the height. If you think about this as being 2, then this length is 1. So using Pythagorean theorem, L squared, I end up finding that L is the square root of 5 times the square root of 5. All right, now for the prism, I have two bases. 2 times 2 is 4. The perimeter, 2, 4, 6, 8. And then the height. If it's standing on its square, this thing is 4 tall. All right, and then I'm going to subtract out the two squares that are within it. So 2 times 2 is 4. I recommend starting with the 4 and working your way across in your calculator. There really are a lot of kind of calculations. If you want to go through and simplify things, for instance, 1/2 of 8 is 4. I could do 8 times 2, or I'm sorry, 2 times 4 is 8, plus 32 minus 8. If you want to break anything down any lower for yourself, it can only help. But go ahead and type all this in, and assuming that I typed it all in right, this is what I got. I just want to take a moment to say that this by no means is the only way to do it. You could add up every single face. You could tweak your formulas a little bit so that you don't have to subtract, but I have found that this is the most consistent method. Go ahead and look at letter B. I'm going to change colors here. So we have a triangular prism, and we have this rectangular prism. If you think about this object as being hollow, if I wanted to fill it from the bottom all the way to the tippy top with something, these would have to be gone. They'd have to be cut out. They don't actually exist. So I'm going to have to take out this bottom piece here and the top piece of this one so that if you were to stack one on top of the other, you could fill it all the way from the bottom to the top. All right, so now it just goes back to some calculations. We have, this is a prism. It is not a pyramid. It's a triangular prism. Notice that its two faces are triangles, and it's created then by rectangular sides. So it's going to be 2 capital B plus PH. This also is a prism, and I'm going to subtract out 2 of those rectangles. All right, the base. I know it looks like it's sitting on this rectangle based on the way I drew it, but by definition of a prism, the base are the faces that you name it by. So because I'm calling this a triangular prism, those capital B's here are triangles. So it's going to be 1/2 the base of the triangle times the height of the triangle. So 2 1/2 base times height plus, and I'm going to go down here a little bit, the perimeter of this triangle is 3 plus 4, I need that length calculated, 3 squared plus 4 squared equals, let's call it x. When you do your calculations, you end up with 5. So 3 plus 4 is 7, 7 and 5 is 12. And then height, if you were to actually lay it on its triangle, think about putting that on its triangle. How high into the sky would it go? If you put it on its triangle, it would only go 2 centimeters. All right, so all of this goes with the triangular prism. Let me switch colors. Everything for the rectangular prism I'm going to do here in green. I have 2 rectangular prism, so that's 8. Perimeter, 2 plus 2 is 6, so that's going to give me 12. And if it's sitting on its bottom, it's reaching 3 into the sky. Plus 12 times 3. And I guess I might as well switch color. Again, even though it looks like these are here, that there is something in here, it's really not, because again, it's a hollow object. So I need to subtract out what the dimension of 2 of those rectangles would be. One that would go in the bottom of the prism, triangular prism, and one that's in the top of the rectangular prism. So that's going to give me 8. If you want to simplify any of your calculations, it can't hurt. Let's see. This is going to give me 12. Half of 12 is 6. 6 times 2 is 12. So 12 plus, that's 24. So 36. And I'm going to add it to this other one over here. And then I'm going to subtract those 2 rectangles, which is 16. Assuming I did all my math correct, I ended up with 72 centimeters squared. These can be a little confusing, and please don't get frustrated. Work together if you need to, but the purpose is for you to go through, figure out what 2 shapes you have, calculate their areas, and then subtract away any common pieces that really aren't there. 2 more examples. Okay, 2 more examples. We have a composite figure here in letter C that's made up of 2 rectangular prisms. I have this big rectangular prism that's on the bottom, and it's the whole, I'm going all the way across and using the whole rectangular prism. So I have that great big one. Beautiful drawing here. It's 30. I know it looks like the 20 is right over here, but the 20 is really going all the way over. See the 15 that's hiding back here? That's really the height of this prism. 15. This is 15. So that's really 5, which is how we got added up to the 20. So I have 15 height by 40. The other prism is this really skinny one that's up here on top. It has this skinny base, or this skinny kind of rectangular bottom, and then up through here. You may not need to draw pictures, and I'm sure these wouldn't be quite so sloppy if I weren't on the tablet, but it's the best I can do. The face of this, notice these little tick marks here is telling you that all of those are 5. And then because it goes the whole stretch back, it's the same like depth as that bigger prism, it's going to be 40. Think about taking sand or whatever and filling this object. These rectangles in here can't really be there because otherwise we wouldn't be able to fill all the way from the bottom up to the top of the object. So this time when I go to subtract rectangles or subtract common pieces, I'm going to subtract 2 of those long skinny ones because there's one here, even though it's not drawn, it's really here blocking. And there's one here that's blocking the flow of whatever you'd want to put into the shape. Going from, I mean, picture that blue thing being there, you just fill up the red shape. Both of those pieces need to almost be cut out so that we could fill through the red all the way up to the green. All right, so formulas. Calculating surface area, 2 capital B plus pH. So I have 2, I'm going to use the base as being 30 times 40. The perimeter is 30 plus 40 plus 30 plus 40. So that ends up giving me 140. And then if, and it is, on the base, how high does it reach? It reaches 15. So that's going to give me 2 times, that's 1200. So 2 times 1200 plus 140 times 15 gives me 4,500. Now for that red shape. It's a prism as well, so 2 capital B plus pH. There are 2, I'm going to use this 5 by 5 square as the base, so that's 25. The perimeter is 5 plus 5 plus 5 plus 5, so that's 20. And if you were to stand it on this square, how high into the sky would it go? 40. So 2 times 25 is 50, plus 20 times 40 ends up giving me 850. And then that long skinny rectangle, like I said, and I know it doesn't look like it's drawn here, but it really is calculated into this, which is why I like this method of subtracting out the common pieces. And it's also in the bottom of this one over here because it's blocking, like I said, whatever you'd want to pour into it, sand or whatever, from getting from the top to the bottom. So this is 5 by 40. So 2 times 5 times 40, because again, there are 2 of them. So that's going to give me 400. So those values all added up gave me 4,950 centimeters squared. All right, so for sake of time, I only get a 15-minute free recording, so I'm going to go ahead and stop this one and start one more so that I can do letter D without having to rush you.